Hey everyone, it's Phil again. We're going to do an activity next, which is focused on machine learning. Machine learning is an increasingly popular part of sort of the data-driven aspect of computer science that is, in the news and pretty much everywhere you look. All the cool new technologies are using some form of machine learning to help computers make decisions, and that's something that I think is really empowering for kids to understand. So what I'm going to show you is a website that has been created to help students develop training sets so they can train machine learning models and then write simple programs in Scratch that then use the information that the training set has taught the computer to do something interesting or interactive. Okay. Now, the connections to science education, I think, could be numerous. I'm not sure I'm creative enough or currently scientific enough to know, but maybe Steve and Sarah and the gang and College of Science Outreach at Purdue can take this in some fun and interesting directions. I'm just going to walk you through an example activity that you can do with your kids that will give them a sense of what machine learning really is. And I think once they know that, then you can take those next steps. Now, we'll say that machine learning is a very complex thing. As a computer scientist myself, I went first I should say when I was an undergraduate way back when, people were probably doing this, but not in the context of courses. So I couldn't have taken a course on machine learning just because there wasn't enough data to make it worthwhile. Now that we have so much data, people are doing more and more of this, but you certainly have to learn a certain amount of computer programming and those kind of skills before you're ready to take on machine learning. So that's why this is a good activity, because they sort of abstract away a lot of the more complicated details and let you just get to the general idea of what goes on in a machine learning algorithm, or the way that you might train a computer to think. Okay. So I'm going to take you to the website, and then we're going to, and I'm going to talk you through some of the setup, because this is definitely something that requires some forethought. You're going to have to put a little time into it on the front end in order to make it a rich experience for your kids on the back end. Okay, so let's take a brief pause and let me show you what we got. All right, this is the website called machinelearningforkids.co.uk. It is British. Okay. And you'll notice right off on the front page, it says teach a computer to play a game. That could be a fun one to do, I'm sure. We're going to do one that actually teaches it to recognize color. Okay. And I want to point your attention or draw your attention to these links at the top. That's where you can get a lot more information. So, those of you who are good at figuring things out on your own, you can just ignore the rest of this video if you want and kind of get into it. But I just want to highlight that it does have worksheets ready for you. So if you want to give your kids worksheets, you can do that. And this thing that says pre-trained are models that have already been trained. So that's a time-consuming step that you're going to have to decide whether you want to do with your students or not. I think it's worthwhile because it's fun. But if you do want to use a pre-trained model, those exist here too. The other thing you'll notice here is that it says log in. Now, this is the piece that you're going to need to do. And you have two options. You can either do the complicated way, which might be instructive for you as you learn more about how to set things up and learn more about machine learning. You can actually go and set up your own API key, which is a way that your programs can talk to Watson, which is the computer that runs behind all this, that does the learning for you. Or you can contact the guy who runs this website and have him set up basically the things that you need, and that way you can avoid all the technical details. So I would probably recommend doing the latter. I have some background in CS, and it took me a little bit to get it all set up, doing it the hard way. So make your own decision on that. What we're going to do is we're going to click on Get Started. And what you'll see here is, what you'd expect, right? First time here, sign up, already registered, log in, try without registering, try it now. I would recommend that you have your kids sign up. And obviously you're going to need to sign up, because if you sign up, you will get to do the background steps that you need to do to get things set up for your class. Okay. I'm already registered, so I'm going to log in, and I'm going to hit pause here for a second, and we'll come back in a minute. Okay, I'm back. I can see now that I'm logged in, I now have an admin page and my projects page. So I'm going to go to my projects, and you'll notice that I have a project here called Chameleon. I actually made that project by clicking on Add a New Project, and you can set things up here, and this is what you're going to have to do. You can name it whatever you want. I chose to call it Chameleon because that's the purpose of this activity, which you're going to see in a minute. Okay. And what we're going to do is we're going to click on the project once we've created it. And you notice that what it does here is it recognizes images, and I gave it three colors that it's going to try and recognize. You can pick any colors you want. I have to admit, when I made this, I was thinking, oh, gold and black, just like Purdue. And it turns out it's really hard to find good examples of gold on the web. So maybe you pick your own colors, you use your school colors, but make sure they're three distinct colors, ones that there won't be a whole lot of ambiguity. You might want to dissuade your students from saying, let's use blue and purple, or red and orange, or things that are very similar. When you click on the project itself, it has 3 steps. There's the training step, there's the learn and test step, and there's the make step. What we're going to do is we're actually going to engage the kids with all 3. The training step is important. This is where we provide examples that the computer can learn from. And so what it tries to do when it's training is it tries to find similarities between multiple objects that are classified using a label. And so what we're going to do when we hit train is we're going to start to build things associated with our labels. Now, when you set up the project, you'll have set up 3 different possible labels, okay? And what you need to do is you need to actually provide examples. What I did when I provided examples here is that I went and I clicked on the www, and I provided a image link. And so I just spent some time on Google and found some blue images. There's Blue Man Group, and I don't know, there's a Blue Jay, and there's blue from Blue's Clues. So I have all these blue things, right? And then for gold, I kind of went down that pathway with a golden retriever and a gold band, and of course Purdue Pete. And then for black, I kind of found some cool things: Black Panther, Black Beauty, some black sneakers, Black Power, all these cool ideas. Space, I'm a big vinyl collector, so I got some vinyl on there. You want to have roughly 20 examples for each. So if I scroll down on any of these, you'd see I have as many as I can find, right? And what's cool is if you set up a class account, you can actually have your students all contribute examples to the same project. So that way it ends up having a lot more training data, and that will help improve the accuracy of the machine learning algorithm that works on the opposite end, okay? Once you have your students do this, and again, build in time to do it, it's really fun for them. They can pick, speaking to student motivation, right? This allows them to pick things that mean something to them, which is really, I think, exciting for them. Once you have that data, then you're going to go back to your project. Now you're going to click on Learn and Test. This is the part that you might be able to use if you and again, you're going to practice this before you go in front of your students, of course. But if you do this in a really thoughtful way, you should be able to use the Learn and Test step to talk a little bit about machine learning, and then while it's doing the work behind the scenes, because you're basically going to send a request to a computer connected to the Watson engine, and it's going to try and learn your patterns that you've provided with this image data. And then that's going to take some time. So what's going to happen, if you see down here, is it reports to you on what you have, and this is the last model that I ran. But you can test the current model once you have it run. But if you were coming here the first time, it won't have a model ready for you, right? So you're going to come down here, and I'm actually going to do this so you can just see what the page looks like. I'm going to delete the current model. Now you see up here, it just tells you, oh, you've got these examples. And now you need to train a new machine learning model. And so what you're going to see when I hit this button is it's going to give you a spinning wheel. And eventually it's going to report back to you that it's started. But you are probably going to have to wait 5 to 10 minutes. And really, depending on the time of day, it could even be more. I mean, I don't know how many people use these tools or how active Watson is. Here you can see it says model started training Monday, Eastern time, 3:30 p.m. And it will be training that model for several minutes. And you can go ahead and refresh, or you can cancel your training. Now, this is a step you could take as the instructor, but once you do this step, you don't need to stay on this page, okay? Now you can go back to your project and you can start the make phase. And this is where we get to do a little bit of programming. And the fun thing about this is, depending on what other tools you want to use, you can use Scratch, which I think is really rewarding for the kids because it gives them a opportunity to program with a real visual environment. Or you can go and do Python if you've already done some other things with Python. And there's some other tools on there too, App Inventor, which is another MIT tool for designing apps, which is, I'll say it can be cool. How's that? So we're going to hit make. Here are your choices. I'm going to use the new version of Scratch, which is Scratch 3. And it's going to give me some information about what I'm going to be doing. And so those of you who are familiar with Scratch know that it's a block-based language. And basically what it does is if you open this project in Scratch 3, oops, sorry about that, it's going to give you new blocks to use. It's going to give you this block here, which you replace the word image in here with a picture, and that will try and recognize that picture and return a label to you, okay? So that way, you know, if you give it a picture of, you know, let's see, if you give it a picture of who's that really big guy who plays for Purdue right now? I don't want to date this video if you're watching it in the future, but there's this really big guy who plays Purdue basketball. Maybe you find a picture of him. I can't think of his name right now. And you plug it in there. Will it recognize it as gold? Will it recognize it as black because maybe the background isn't showing it or his hair is dark or whatever? So this will give you whatever label it comes up with. It's not guaranteed to be right, okay? Then there's another block that actually tells you the confidence level that the computer had based on some statistics that go with this process. So it'll give you a number between 0 and 100. I know some of you probably saw Watson play Jeopardy, and that's how this worked, is it basically created a confidence interval for each answer and tried to go with the highest confidence. And then lastly, you can actually use the label if you want so that you can use it in your script, okay? And we're going to use these things in the context of a Scratch project. Now, we're going to do that in another video, but I'm going to go back to learn and test because I want to see what happened while I was talking. Now, notice that it doesn't look like the model is finished, but I'm going to refresh my page anyway, just to make sure I've got the most up-to-date data. Yeah, it's still working. So hopefully, when we come back in the next video, I will have a working model, and we can start doing the Scratch programming part, which should be really fun. Okay, it's me, Phil. I'm back. Time to do some more machine learning. Hopefully you had a chance to set things up and have actually started trying to play around with this because I think it'll be really helpful for you if you continue to do that in preparation for using this with your students. Now, if you remember last time I left off on having started training my model, and I want to go and show you what the results were, and then we're going to get to programming with machine learning, which will be the next part, which we'll do in Scratch. Okay, so let's go. So here I am back on Machine Learning for Kids, the website, and you'll notice that it has finished. It took, it doesn't tell me exactly how long it took. I apologize. It's under 15 minutes, I promise. But it does give me some information about testing. So I'm going to go ahead and I will test. I'll test with a World Wide Web link. So let's go to, I use DuckDuckGo as my search engine. So let's search for blue berries. And then we'll go to images. And okay, looks like a good picture right here. So I'm going to, let's copy the link location. And then let's go back over here and we'll put that in there. Ooh, let me make sure because that says HTML. Let me see if I can get the file itself. There we go. So I'll hit Control C. I'll come back over here and I'll Control A and Control V. There we go. Let's test it. And so it says recognized as blue with 91% confidence. So this would be a good thing for you to do with your students, is test a bunch of things and see if they can come up with ones that they expect wholeheartedly to fit their labels and ones that are like edge cases, because then you can start to figure out, well, do we need to train this model more before we unleash it on the world? And then maybe you can start asking those really interesting questions with your students, like, do you think there are machine learning algorithms out there, like say Netflix or Amazon, who already think they know things about you, but maybe don't have the right data to make good predictions. And then from there, you could say, are there any machine learning algorithms or places where you wouldn't want machine learning in case they're wrong, right? There's all these really great ethical questions here. We're going to skip some of that for now. And then we're going to go back to the project and we're going to do the make step. So like I said, we're going to go and make something now that our model is trained, and we're going to go to Scratch 3. Now, Scratch hopefully is something that you've used before. This is, you want to launch it from the Machine Learning for Kids website because it actually makes sure that those blocks are included. Now, if you started Scratch and you didn't do that, you can always add things down here with this. There's add-ons in there that you can use. Now, the other nice thing about going through Machine Learning for Kids to use Scratch is that you can use a project template. So one of the things that I want to do here is actually want to use a pre-existing project. I don't want to use, I don't want to start from scratch completely, no pun intended. So I can go to project templates and I can grab, and there's lots of cool ones in here. You can search around in here to find the one that you want, but I'm going to say chameleon. There you go. And this is a fun one. So I'll move my my own video down here just so you can see a little better. So the way they've designed this project is that now that you've changed a model that can recognize color, what we're going to do is we're going to be able to put an image behind the chameleon, and then based on the image that you put behind the chameleon will try and change color to match the label that the machine learning algorithm predicts for that particular background image, okay? And it turns out it's really easy to write this code. It's not actually that complicated. The worksheets that are provided on the Machine Learning for Kids website take you through this and can be helpful if you're trying to give this to your students. I'm going to go ahead and do the steps. I think I can do this from memory. don't give me too hard a time if I make a mistake. So over here on Scratch, you'll notice that there are a couple tabs associated with every sprite. An image in Scratch is called a sprite. You want to make sure that you've selected the chameleon, which is the drawing of the chameleon here, and you want to go to costumes. Because what we're going to do is we're actually going to, we have the one of the outline, which is cool, but we're going to actually duplicate it. 3, 4, so we have 4 copies. So there's 4 different costumes. In other programs, you could do this to say, make little changes to the graphics so it looks like it's moving or what have you. For these ones, what we're going to do is we're just going to change the color. So I'm going to go to number 2. I'm going to rename it blue. This is an important step. You have to rename it the same thing as the label you used in machine learning when you trained your machine learning algorithm. So if you're, if you decide turquoise was your magic color, then you have to name this turquoise and you have to spell it right. Okay, that's very important. Then I'm going to go ahead and I want to use the paint bucket tool here, and I want to find a color blue. Now this doesn't have to be exact. You can pick whatever pretty color blue you like. I'm going to go with, I don't know, something like that. That looks pretty good. Like a San Diego Superchargers blue, although I guess they're not the Chargers anymore. But anyway, I digress. Okay, and then I'm going to use the paint bucket, and I'm going to come in here, I'm going to click, and that has made that graphic blue. Okay, we're going to repeat that for outline 3. We're going to, in mine, I use gold. So I'm going to go ahead and go find something kind of goldish. I guess maybe I don't know. It looks gold. You can actually go and find the official like Purdue colors if you want. I'm not that. I'm not going to be that critical about it, but we'll call that gold, I guess. And then I'll color them. That looks pretty gold to me. Hopefully old goldish. And then we'll call this one black. And that's really easy to get the color because you just go like that. And we'll color them in. Okay, so now I have a blue, a gold, and a black, and I have an outline. So I can go back to the original one. That's step 1. Once you've got that, you're in pretty good shape. Now I want to talk a little bit about the program itself. So there are a couple pre-made blocks, and let's talk about what's going to happen in terms of the operation of the program. We're going to start our program by clicking on the flag. When the flag is clicked, it's going to switch the costume to the outline character, which is this guy here, the invisible one, and then it's going to hide the character. And when you change the background image, which if you notice this block here, it says, here, let me blow this up a little bit. It says, when I receive a new background, switch costume to that color, and then show it and make sure it's the front layer. Okay, so it seems pretty straightforward. Now, as it turns out, we can look at the branch. Not much going on here with the branch. But if you click on the background itself, you'll see that it also has code. So when you click the flag, it says set the color to the outline and broadcast new background. Okay. What we want to do is we want to change our program so that we can actually have it, instead of setting the color to this outline, we want to set it to the label that our machine learning algorithm has determined based on the background. So what we're going to do is we're going to click over here, and you notice there's a menu item down here called Chameleon. So I'm going to click on that, and I'm going to use this one that says recognize image, and the output is what's in parentheses. It's going to give me a label. So I want it to, pick the right label, and then we're going to set the color to label. Okay. And images, if you click on that one, you notice right here it has the backdrop image. So we're going to plug that in. Okay. So basically, you're giving it a backdrop image. It's going to run the machine learning algorithm with that image, return a label, broadcast new background, and then the Chameleon is going to switch costume to match that color. Okay. So we can go ahead and try that. If you go to the stage, the background, and you switch this up so you can actually add. Like if you look, sorry, let me move my you don't want to look at me anyway. If you go to choose a background, you can do all sorts of things. You can upload a backdrop, you can pick a surprise one, you can paint one, or you can choose a backdrop. Just for me, because I'm just going to try and get a good practice in here, I'm just going to pick one, because they have a whole bunch in here, and maybe one of these will be right. So let's try underwater. That seems like that should come up blue, right? So let me click on the flag, and notice he turned blue, my Chameleon. So it looks like my code worked pretty well. Now, if I change the backdrop again, let's try gold. I don't think I have a good example for gold. That one. Oh, let's try the farm. Let's see if the farm does it. I'm not sure about this one. Let's give it a shot. And then we run our code. Okay, it properly guessed that it was gold. So it's working kind of like I expected to. Now, you could even take this whole program a step further, right? Because you could change the Chameleon's code so that before it switches its costume to whatever color it receives, you could have it ask a question. So as an example, I could do this. Let me go to the control, and I'm going to ask this question. If and actually, hold on a second. I've changed my mind. I don't want to use an if. I want to use an if and an else. So I'm going to plug that in there, and I'm going to put this as the thing to do if it's true. Okay, so remember, if statements are like questions that can branch. So if it's confident about its answer, we'll have it do what it was doing. And if it's not confident, let's go ahead and have them say, sorry, I'll move my little head back there. Say, I'm not sure, exclamation point. And so we go to operators and we find, let's see, the greater than, and what we'll say is, all right, Chameleon, if your confidence is bigger than 50, that seems pretty good, then we'll be confident we'll change color. But if it's not bigger than 50, then we don't know. Okay, so I made the change, and so let's change the background again. This time we'll go to let's go to one of the ones we knew. So let's go to Space City here, and then let's run it. And it looks like it changed to blue, and that's good because it was confident. But if it's not confident, oops, let's go back to this. Let's pick one that we expect it would have a hard time with. Let's try Castle 2. And then I hit my button. Ooh, I thought this was black. Interesting. So that would be interesting. Notice it also says it looks like you might need some help with the recognized image block. So that could also be a challenge. And it might even be that it sent some information that it didn't, that wasn't sure of. So maybe we could even change the code here to see if that that works properly. But the idea here is that you can use this to test your machine learning algorithm, and you can learn some interesting things about how computers actually make those decisions, because it's not as cut and dry as you think. Sometimes you're on Google and you were thinking about buying dog food, and then all of a sudden, there's a Google ad at the top for dog food, and you're like, oh my gosh, the man is the man is listening in. But it's not always that cut and dry. Sometimes there's a little bit of decision making that goes on behind the scenes. So hopefully this has given you a good start at machine learning, and I really implore that you take advantage of the Machine Learning for Kids website, and you go and look at some of these other projects. If you look at, for instance, like if you go to copy template, you can see that they have a lot of built-in ones that you can start with other data sets that are really fun to play with. And you can also go and look at all the worksheets that exist for all the different projects they have. And as I scroll down here, you see there's a whole bunch of those that are fun to play with as well. And like I said, hopefully this is a fun place for you to start. And hopefully some of you will start thinking about some cool applications where you can connect what you are using here in machine learning to some of your science work. All right, have fun.